Good evening, my dear students of 10th standard. I am going to explain you how to solve the numerical problems in this chapter electricity. So, this is based on Ohm's law and a combination of resistors. You look at the problem number 10 given in page number 221. How many 176 ohm resistors connected in parallel are required to carry 5 ampere current on a 220 volt line? So actually how much current is going to flow through the line is 5 ampere, and what is that voltage applied to the line is 220 volt. So what will be the resistance in the circuit we have to find out. To what that resistance, how many 176 ohm resistors are required if they are connected in parallel? That is the question. Okay, so the current given in the circuit is 5 ampere and the potential difference is 220 volt. The resistance in the line is required to be found. Can anyone tell me which law connects these three quantities, namely current, voltage and resistance? Very nice, that is Ohm's law. Okay, from Ohm's law, I will write from Ohm's law. What is the expression for the resistance from Ohm's law? You tell me what is the expression directly for resistance? Good. Yes, R is equal to V by I. So I will write R is equal to V by I, and R is equal to 220 divided by 5. Is it not? You divide, so 5 4s are 20. So the first digit is what? 4. 5 4s are 20, remaining 2. 2 and 0 makes 20. Again what? That is 44 ohm. This, are you all understanding first? So how much resistance of the wire is required here is what? R is equal to 44 ohm. Now this 44 ohm resistance we have to make by combining 176 ohm resistors in parallel. Understood or not? We are given what is the value of the given resistance? 176 ohm resistors, plenty are available, plenty are given to us. Out of them, how to make 44 ohm resistance? We have to plan. The shortcut, shall I tell you? The shortcut is, first you divide 176 by 44. 176 by 44. So if you divide 176 by 44 means, so this will be equal to 4. Is it not? 44 into 4 is how much? 44s are 160, 4 4s are 16, so 176 will come. This is the idea you have to develop. So you should be brilliant in thinking. So how many resistors are required means 4 resistors. 4 resistors are required. Okay. Actually the question is asking you to find how many 176 ohm resistors are required. But we have to verify, is it not? Shall I tell you how to verify? That's good. Okay. So you see here 1 by R parallel. 1 by R parallel is equal to 1 by 176 plus 1 by 176 plus 1 by 176 plus 1 by 176, that is equal to, so 1 plus 1 plus 1 plus 1 is 4. 4 by 176. So this is what? 4 divided by 176. Therefore what? RP. Therefore RP, taking reciprocal on both sides. So this 1 by RP is equal to 4 by 176 means what will be RP then equal to 176 by 4. So this is equal to 176 divided by 4, and you will get that this is equal to 44 ohm. So this is verified. Yes. Have you understood? That's good. Okay. Now another one very brilliant sum is given to us, and that is problem number 11. It is also in the same page number 221. Okay. So how you are thinking, let me see. How you would connect 3 resistors of 6 ohm each. Okay, 6 ohm each. So that the combination has 9 ohm first and 4 ohm next. You are given what type of resistors? Yes, 6 ohm resistors. How many 6 ohm resistors are given to you? Yes, that is good. Okay, 3 resistors are given. Now before getting into this problem, my question, simple question to you is, if you combine all the 6 ohm resistors in series means what will be the total resistance? Come on, you tell me, the first student. Yes, you tell me. Yes, 6 plus 6 plus 6 is how much? That is good, 18 ohm. So we have already studied, no, the maximum resistance you can produce out of the combination is what? If they are connected in series. And the minimum resistance connected will be what? Yes, when they are connected in parallel. Okay, now you tell me, yes, what will be the minimum value of the resistance if all the three 6 ohm resistors are connected in parallel? 1 by 6, 1 by 6, 1 by 6 will be what? 3 by 6. Reciprocal will be what? 6 by 3. That is equal to what? 2 ohm. Okay, 18 ohm and 2 ohm. How to find out? We know it. But what is asked here is 9 ohm and 4 ohm. So you have to think brilliantly. 9. 3 resistors of 6 ohm are given. We know that 6 plus 3 is 9. Is it not? So I will tell you a shortcut. So the first one is you can split 9 ohm as what? 6 ohm and 3 ohm. So this can be written as 9 ohm. 9 ohm is equal to 6 ohm plus, see, like this, 6 ohm. So this is what? 6 ohm resistor. And the parallel combination of 6 ohm resistors like this. So this is 6 ohm and this is 6 ohm. Is it not? So if two resistors of equal values 6 ohm are connected in parallel, means we have already studied that the effective combination in parallel is what? Half of the single resistor, that is 3 ohm. So the equivalent resistance for this also can be written as, so this is equivalent resistance will become what? 6 ohm and 3 ohm. So this is 6 ohm and this is 3 ohm. Is it not? So here this R parallel is equal to what? This is what? 3 ohm. So 6 plus 3 ohm. 6 plus 3 ohm is equal to what? 9 ohm. So this 6 ohm plus 3 ohm will be equal to 9 ohm. Have you all understood? Okay. In the same way, now the second case. The second case, you think now. We want to get what? 4 ohm. The other way you think. Here one resistor is separated and two are connected in parallel. Like that. Now what? 2 in series we will connect. What will happen? Let us see now. So this is one resistance of 6 ohm and this is connected in series. This is connected in series with another 6 ohm and the combination is connected across another 6 ohm. So this is 6 ohm, this is 6 ohm and this also is 6 ohm. Now what is the sum of these two resistance? 6 and 6 are in series. 12 ohm. You are right. 12 ohm only. Okay. So it should be, yes, it should be a parallel combination of, you are right. Come on. 12 ohm and 6 ohm only. That's good. So the equivalent resistance for this is what? 12 ohm. So the first resistor is what? 12 ohm. And the parallel resistor is again another 6 ohm. Okay. So 6 ohm. How will you find the combination? This 1 by Rp as usual. So this is 1 by. So this is 1 by R parallel is equal to what? I have told you 1 by 12 plus 1 by 6. So this is 1 by 12 plus 1 by 6. So this is also equal to 1 by 12 plus 2 by 12. I have multiplied by 2 and here also multiplied by 2 so that it will become what? 2 by 12. So totally how much? 3 by 12. So this is equal to 3 by 12 and this implies reciprocal. The reciprocal Rp will be equal to what? 12 by 3. So therefore we can write R parallel is equal to what? 12 by 3 and that is equal to 4 ohm. Understand? But without using the formula, I told you when two resistors are connected in parallel, that is direct formula is there. So what is that? R parallel. Therefore R parallel also is equal to what? A product of them. 12 into 6. 12 into 6 divided by 12 plus 6. Is it not? So this is equal to what? 12 into 6 divided by 15. Okay? 12, that is this is 18. This is 18. 6. So now how it is divisible? All are divisible by 6. All are divisible by 6. So this is 6 2s are 12 and this is 6 3s are. So this is again 2 into 6 is what? 12. 12 divided by 3 is equal to what? That is also equal to 4 ohm. So this is for verification purpose. Whenever in competitive exam like NTSC or in higher level exams like the JEE and all, verification must be done. You cannot directly click the answer. You have to verify by another method, but that too very quickly. I hope you must have understood these two sums. Shall we proceed for the next sum of the interesting sums in the exercise? That's good. Okay. The next problem is 12, page number 221. compare the power across the 2 ohm resistor in each circuit. So there are two circuits given to us. The first circuit consists of two resistors 1 ohm and 2 ohm connected in series. And the second circuit consists of two resistors containing 12 ohm and 2 ohm in parallel. Okay. Now how much power will be distributed over the 2 ohm resistors in each case? How much power will be dissipated across the 2 ohm resistor only we have to find out. Okay. Now we have already studied in a circuit consisting of series combination of resistances in series, that is I is equal to constant. Is it not? The current will be constant. And in parallel combination, the current sent by the battery will be distributed like this. So if this is I1 ampere, this will be I2 ampere. Current will distribute across the two paths. But what will be constant? Yes, the potential difference, that is the voltage V will be constant. So the potential difference across one, that is the first resistance 12 ohm, second resistance 2 ohm, both will be V volt only. Okay. And here the current through 1 ohm resistor and the 2 ohm resistor will be the same. Okay. Now we will first find out what is the current flowing through the circuit. So for that you tell me what is the value of the combined resistance here. They are in series. So R must be equal to what? 1 ohm plus 2 ohm. So this is equal to how much? 3 ohm. So the resistance is equal to 3 ohm. And what is the potential difference given here is 6 volt. Therefore, how will you find I is equal to from Ohm's law? Yes, you tell me from Ohm's law what is I is equal to V by R. That's good. So I is equal to V by R. So this is equal to V by R, that is equal to 6 volt divided by 3 ohm, and this is equal to 2 ampere. So what current is flowing through both the resistors? Same current, that is 2 ampere only, is flowing through both the resistances. Now we have to find how much power is dissipated across only the 2 ohm resistance. Therefore the power dissipated across the 2 ohm resistance, okay, this is equal to I square into R. So this is equal to I square, that is 2 into 2. I is equal to 2, therefore I square is equal to what? 2 into 2 into what is the resistance across which we have to find the power? That resistance only we have to substitute. Only 2 ohm resistor they have asked. Therefore this is equal to what? 2. So this is equal to 2 into 2, 4. 4 into 2 is what? 8. And the unit of power is watt. Have you all understood? Yes. In series combination of resistors, current will be constant. So which formula we have to use is power is equal to I square into R. Now in the second circuit, is the current constant through both the resistors? No, it is dividing as I1 and I2. But what will be constant? Good. The potential difference across 1 ohm, that is 2 ohm and 12 ohm, both will be the same. And hence here the power must be equal to across the 2 ohm resistance. So the power across the 2 ohm resistance must be equal to V square divided by R. Is it not? Because in the same formula I is equal to V by R, if you substitute it will become V square by R square into R, and you will get what? V square by R. If voltage is constant, you have to use this relation V square by R. You substitute now what is V? V is equal to what? 4 volt. Is it not? So V square will be equal to what? 4 into 4, and divided by which resistance you have to substitute? Only the 2 ohm resistance, and divided by 2. So this is equal to 16 divided by 2, and that is equal to what? 8. And the power has a unit of watt. Very simple. Have you all understood? Once again I am repeating you, my dear students, in the series combination current will be constant. So power dissipated is given by what formula? P is equal to I square into R. Whereas in parallel combination the voltage is constant, and hence the formula to find the power dissipated is P is equal to V square by R. Okay, now let us go to the next problem, number 15, which is again very interesting problem. And you read here, 2 lamps, bulbs, okay, which are rated as 100 watts 220 volt and 60 watts 220 volt are connected in parallel. So 2 bulbs are connected in parallel. What is the current drawn from the line, that is from the battery, if the source voltage is 220 20 volt. So first for the circuit diagram, if you draw, means the first bulb is having a resistance like this and the second bulb is having a resistance like this. Do you remember the symbol for the electric bulb is filament? Okay, good. So this is the bulb 1 and this is the bulb 2 and they are connected in parallel across a 220 volt source like this. Okay, 220 volt source. So this is 220 volt and this is 100 watt and the second bulb is what? This is 60 watt. Since they are connected in parallel, you tell me, will the potential difference across them will be same or different? Just now we have seen. You are right, that's good. The potential difference across both the bulbs will be what? 220 volt. Is it not? So what is asked here? What is the current drawn from the line? Total current. The total current drawn from the line is being asked. So here the current which is flowing through the first bulb. Let us take this is the first bulb. So the current is I1 ampere and the current through the second bulb is I2 ampere. Because just now in the previous circuit also I told you that the current supplied by the battery is having now two channels or two paths through which the current will divide. So that the total current supplied I is equal to what? I1 plus I2. So they are asking the value of I. So shall we find I1 separately and I2 separately and add? That's good. By using Ohm's law to each part of the circuit, we are going to find what is the current flowing through each bulb. Okay. So now in both the cases, the potential difference is 220 volt. Now you tell me I is equal to V by R. So this is I1 is equal to V divided by R1. This formula we cannot use because power is given. So this is also equal to, that is power divided by voltage. Okay, power P1 divided by voltage. So out of these two expressions, which can be used? You tell me. I have written both the expressions. Which can be used? First one or the second one? You remember both, but which is required here is the second one, because power is a product of voltage and current. We need the current. So voltage is given, power is given, means this expression we can use. Okay students, so this expression we are using. So this is I1 is equal to, what is the power of the first bulb is 100. Okay, substitute. So this is 100 divided by 220. So 0 get cancelled. This is 10 divided by 22 and this is equal to 5 divided by 11 ampere. 5 by 11 ampere. Good. Like that. Now anyone, you tell me now what is the expression for I2? Both expressions you tell me. Yes, what is I2 equal to? Yes, potential difference V divided by R2. But since the resistance is not given, which formula also we can substitute is this is equal to P2 divided by V. So this is the expression we require. I told you remember both always. And here you substitute P2 divided by V. So now I2 is equal to what? What is the power of the second bulb? 60. Okay, so this is 60 divided by, what is the voltage? Same, 220. So 0 is getting cancelled and this is equal to what? 6 divided by 22 and this is equal to 3 by 11 ampere. 3 by 11 ampere. Is it not? So what is the individual current flowing through each bulb? Okay, I1 is equal to 5 by 11 ampere and I2 is equal to what? 3 by 11 ampere. Yes, now you tell me how will you find the total current flowing from the line? Okay, therefore total current, the total current I is equal to, the total current is I equal to I1 plus I2. So this is equal to 5 by 11 plus 3 by 11 and this is equal to what? 8 divided by 11. 8 by 11 ampere. Okay, good. So this is 8 by 11 is what? Less than 1 ampere. Some 0.57, 0.67 like that, some value will come. So the total current is the sum of the individual currents flowing through each bulb. That is I is equal to I1 plus I2. That is equal to 5 by 11 plus 3 by 11 and that is equal to what? 8 by 11. Okay. Have you all understood? Okay, that's good. Let us go to the last set of 2 or 3 more problems. Until then, have you noted this? Okay, shall I rub the board? Now, look at this problem. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So first we will write what are all the informations given. So the resistance of the iron is given as what? 20 ohm. So R is equal to 20 ohm. It takes a current of 5 ampere. So I is equal to 5 ampere. And the heat developed in a time is equal to what? 30 seconds. So I is given, R is given, and T is given, and heat energy developed in the resistor, that is H is questioned. What is the law which is connecting these three quantities, or which law is helpful to calculate the heat developed in a current carrying conductor? Yes, you tell me. Good. That is Joule's law. Okay. So from Joule's law, so this is based on which law means Joule's law. Okay, Joule's law of heating. What is the expression of Joule's law of heating relating these three quantities? Can anyone tell me? Yes, the second row back, you tell me, come on. Yes, H is equal to I square R into T, that's right. So H is equal to I square R into T. So calculate the heat developed means heat energy developed is given by the expression H is equal to I square RT. So this is equal to what? I square. So this is 5 into 5 into R is 20. So this is 20 into T is how much? 30. So this is 30, and this is expressed in joule. The unit is joule. So this is equal to 5 into 5 is what? 25. So this can be written as 25 into 20 multiplied by 30. So 25 into 2 is 50. So 25 into 20 must be what? 500. So this is equal to what? 500 multiplied by 30. So this is equal to 5 3s are 15 followed by 3 zeros, joule. So this can also be written as 15 kilojoule. 1 kilojoule is equal to 1000 joule. Therefore, the answer can also be expressed in kilojoule. So the heat developed in the resistor of the iron box is what? 15,000 joule or 15 kilojoule. I hope you must have understood. Okay. The last problem of today's discussion will be: an electric motor takes 5 ampere current from a 220 volt line. Determine the power of the motor and energy consumed in 2 hours time. 2 hours. So what are the given quantities? One by one we will write. So what is the current given here? Current is equal to what? 5 ampere. Then voltage, potential difference is equal to how much? 220 volt. And the time taken is equal to what? 2 hour. 2 hour. Now we have already studied that that is power. Power P is equal to what? Power P is equal to voltage into current. Voltage into current. And energy. Energy is equal to what? Here what is asked? Both power as well as energy is asked. So first of all we will find that power is equal to voltage into current. So this is equal to 220 multiplied by 5. So this is equal to 25s are 100 and 25s are 100. So this will be equal to 1100 watt. 1100 watt. Power is equal to what? The product of voltage into current, and that is found to be equal to what? 1100 watt. So now the energy. So the energy I will find out here. This energy is equal to, okay, energy E is equal to power into time. Because power is the rate of consuming the energy. So power P is equal to what? E by T. Therefore energy must be equal to the product of power and that time. So I am substituting that this is equal to what? 1100 watt into how many hours? Yes, 2 hours. So this is equal to 11 2s are 22. So this becomes 2200 watt into hour. Watt into hour also is what? Is a unit of energy. But which is the commercial unit of energy you have heard? Good. Kilowatt hour. Okay. Kilowatt hour we have already defined. 1 kilowatt hour also is equal to what? 3.6 into 10 power 6 joule. So we are going to express this in kilowatt hour, means I should divide this by 1000. So that this is also equal to what? 2.2 kilowatt hour. So this is also equal to what? 2.2 units. So 2.2 units. Yes, have you all understood? Yes. So for this, power is equal to voltage into current. Then energy is equal to power multiplied by the time taken. We find that the power is 1100 watt and the energy is 2.2 kilowatt hour. Have you all understood? Okay, well students, with this the entire chapter is getting over with a thorough revision of both the concepts, derivations and the numerical problems also. Next you should prepare this thoroughly and be ready for the test which we will conduct by giving reasonable time. Until then, goodbye.